To help you out with factoring, I have made some hierarchies of how to follow the steps of how to factor. I'm going to show you how we can use this chart when we are factoring polynomials. So I'm going to go through some examples that we have seen before and how we can follow the chart. The first example, 15x plus 12. So I'm going to start off with the first question, do you have a common factor in both terms? Yes, I do. So I'm going to continue along this path. So then I'm going to divide out what is in common. In 15 and 12, I can divide both terms by 3. And I would be left with 5x and a positive 4. All right, continuing through the chart. Next step, can what is left inside of the parentheses be factored more? So looking here at 5x plus 4, is there a common factor? No. Is there a difference of squares? No. So neither of these two cases would apply to this situation. So I would go to no, you have your final answer. So this is the final factored answer of this problem. All right, next up, let's take a look at this polynomial. 26x squared plus 2x. So the first step is, do you have a common factor in both terms? And yes, we do. So then we will divide out what is in common. So I'm looking and I see that there's a 2 in common, so I guess I'll factor that out. Okay. Then I continue to the next step. Can what is left inside the parentheses be factored more? So is there another common factor? Looking inside the parentheses here, 13x squared plus x. Oh, I see that there's another factor in common. They both have an x. So I'm going to need to then, continuing down, go back to the first step to find a bigger number or variable to divide by. So instead of just dividing by this 2 here, I should be dividing by 2x. So then that's going to change what's inside the parentheses. I'm going to be left with 13 and now just 1x and now plus 1. So then from this point, so I went back to the beginning, I divided what was in common. Now, is there anything else that is in common in the parentheses that I can factor out? Nope. All right. Is there a difference of squares? Nope. So then, no. I have my final answer. So this here is the final factored answer of this polynomial. All right, the next one, 12x squared minus 27. So first step, do you have a common factor in both terms? 12x squared, 27, Yeah, these can both be divided by 3. So yes, there is a common factor. So I'm going to divide out what is in common. So I will take out the 3, and I'd be left with 4x squared minus 9. All right, next up, can what is left inside the parentheses be factored more? So first I'll check, is there another common factor? Inside here, 4x squared minus 9. There's not a number they both can be divided by. They both don't have an x, so nope, there's not another common factor. Next up, is there a difference of squares? So a difference, am I subtracting? Yes. Do I have 2 square numbers? Can I take the square root of both of these? Yes, I can. So I'm going to continue down this path then. There's a difference of squares. So I'm going to find the square root of each term and make one parentheses plus and the other minus. So this 3 stays the same. I'll take the square root of the first one, and then the square root of the second one. This parentheses will be plus, and this one will be minus. All right. So then from here, can what is left inside the parentheses be factored more? 2x plus 3, we don't have a common factor, we don't have a difference of squares, so nope, and nope again. So then we would go down to the no path, and we have our final answer. So this here is the final factored answer of that polynomial. All right, so the last example I'm going to show you for this hierarchy where we have two terms in our polynomial is x squared minus 25. So our first step is, do you have a common factor in both terms? An x squared and a 25. Nope, nothing is in common there. So then the next step, is there a difference of squares? X squared, 25, are those both square numbers? Can we take the square root? Yep. Do we have a difference subtracting? Yes. So we're going to go down this path. So then find the square root of each term and make one parentheses plus and the other minus. Square root of x squared, x, square root of 25, 5, one parentheses is plus, the other is minus. Next up, can what is left inside the parentheses be factored more? Anything in common or a difference of squares? Nope. So then you have your final answer. And I lied, I'm going to show you one more. So let me erase this highlighting. And the other one I'm going to show you is this, x squared plus 25. So we always start off the same. Do you have a common factor in both terms? X squared and 25? No. Is there a difference of squares? So let's see. We have two square numbers, but do we have a difference? No, we do not. It's adding, not subtracting. So it is a prime polynomial. There's nothing in common. It's not a difference of squares, so it cannot be factored. Now we're going to get into factoring polynomials that have three terms. When we have three terms, you can see this chart, it's a little bigger. We have more things to check and more possibilities of ways that we can factor this. But you'll notice this chart starts off the same. Do you have a factor in common in all three terms? X squared, 10x, 24. No, there's not anything in common here that can be factored out of all the terms. So the next is the number next to the variable squared, a 1 or an invisible 1. So here's our x squared. The coefficient, the number next to it, it's an invisible 1. So our answer to that question is yes, it's an invisible 1. So then factor by looking for two numbers that multiply to c and add to b. So this is where we're looking to see what multiplies to 24 and what adds to 10. So some thoughts. 1 times 24, those don't add to 10. 2 times 12, we're trying to get a positive 24. And positive 2, positive 12, they don't add to positive 10. 3, no. 4 times 6, yes, those two are the two that add to 10. So 4 and 6 are the two numbers we will use. So then, following along, we have yes, there are two numbers that satisfy the conditions. They add to 10 and they multiply to 24. So then write the answer as x plus or minus the one number and then x plus or minus the other number. So we have two parentheses, x and x, with a positive 4 and a positive 6. Next up, can what is left inside the parentheses be factored more? Do we have a difference of squares? Do we have factors in common? No, nothing is in common. There's not a difference of squares, so you have your final answer. All right, moving on to the next one, 2x squared plus 7x plus 6. So we start off the same always. Check to see, do you have a common factor in all three terms? 2x squared, 7x, 6. Well, we have a common factor in a couple of them, but there's not one common factor in all three terms. So I'm going to have to go with the no direction here. Is the number next to the variable squared a 1 or invisible 1? So our number next to the x squared is a 2. So no, it's not a 1 or an invisible 1. So I'm going to have to go down the no path. So then factor using the AC method. All right, so first, AC, 2 times 6, 12. Now I'm looking to see what multiplies to 12 and what adds to 7. 1 times 12, nope. 2 times 6, no. 3 times 4, yes. So then we break this apart. The 7x, we can split it up into 4x and 3x. Then we divide it into groups to get 2x times x plus 2 plus 3 times x plus 2. The parentheses are in common, so I'm going to factor that out. And I'm left with a 2x and a plus 3. All right, so I factored using the AC method. Let's see what comes next. Can what is left inside the parentheses be factored more? Do we have a common factor or a difference of squares? No, we do not. So going on this path, you have your final answer. Yay! So this is the final factored answer of that polynomial. So next up, let's look at this trinomial. 7x squared plus 14x minus 56. It's a trinomial, so we will use this chart again, but no matter what kind of polynomial it is, we always start off the same. Do you have a factor in common in all three terms? Let's see. 7x squared, positive 14x, negative 56. All three of these terms can be divided by 7, so we're going to follow the yes path. So we're going to divide out what is in common. So we will divide out a 7. We'd be left with x squared plus 2x minus 8. All right, next up. Can what is left inside the parentheses be factored more? So first, let's check to see, is there another common factor? So x squared plus 2x minus 8. Is there something else in common I could take out here? And no. So then next up, yes, and the number next to the variable squared is a 1, or an invisible 1. Or is the number next to the x squared another number that's not 1? So looking next to the x squared, we have an invisible 1. So let's try out this path here, and we're going to see if this will work, if we'll be able to factor this. If not, then we'll have to go down the no path. So if we're trying out this path here, we're going to factor by looking for a number that multiplies to c and adds to b. So we're looking for what multiplies to negative 8 and what adds to positive 2. So 1 and 8 make 8, but that doesn't add to 2. 2 times 4, and I know 1 is going to have to be negative. 1 will be positive since the 8 is negative. And 2 and 4, yeah, I can make a positive 2. If the 2 is negative, when we add those up, negative 2 and positive 4 will equal positive 2. So then I know that this path is going to be the right one for me because there are numbers that will multiply to c and add to b. So then it says to write the answer for this part of the factoring as x plus or minus something times x plus or minus the other one. So I'll keep the 7 at the beginning. Then I'll factor the inside trinomial here, x minus 2, x plus 4, the two numbers we discovered. So then next up, can what is left inside the parentheses be factored more? X minus 2, is that a difference of squares or a common factor? No. X plus 4, no. So it cannot be factored more, so we have our final answer. Next up, this will be our last example of a trinomial using this chart here. So last up, we have 6x squared minus 28x minus 10. We always start the same. do you have a common factor in all three terms? So 6x squared, negative 28x, minus 10. Is there a number we can divide all three of these terms by, or a variable? And the answer is yes. We can divide them all by 2. So yes, we have a common factor, so we will divide out what is in common. So I'll take out the 2. We're left with 3x squared minus 14x minus 5. So then at this point, we'll continue going down the chart, and it says, can what is left inside the parentheses be factored more? So we're checking to see if this portion here inside the parentheses, if this can be factored anymore. So first I'm going to check this one. Is there another common factor? 3x squared, 14, 5. No, there's nothing that can divide into all three of these terms. So then I'm going to go to the next ones. And these are pretty similar, but one would be that the number next to the x squared is 1. The other is that the number next to the x squared is a different number. So let's see what we have. Next to the x squared, we have another number. We have a 3. So then that means let's try out this path. Let's see if we can follow the AC method and get it to factor. If we try it out and it doesn't work, then we'll need to go down this no path. But first, let's try this and see if we can factor this using the AC method. We're trying the AC method because we have another number here besides 1. We have a number here, we use the AC method. So AC, in this case, 3 times negative 5, negative 15. So I'm going to check to see what multiplies to negative 15 and what adds to negative 14. Ooh, right away, I think I got it. 1 and 15, 1 will have to be negative, 1 will be positive, and I can make a negative 14 by adding these if the 15 is negative. So then keep the 2 out here, just chill in there. But then I'll rewrite this trinomial, but now splitting up this minus 14x into minus 15x and plus 1x. The rest of the trinomial stays the same. And I'm going to keep going through the AC method. So I'm going to put these in groups now. And in common in this group is a 3x. I'm left with just a 1x minus 5. In the next group, all that's in common is a positive 1. So I'm left with the x minus 5. Now these parentheses are in common. 2, notice how the 2 is still just stays there the whole time, just stays there out in the front. So then I have x minus 5 is in common, and I'm left with a 3x and a plus 1 after I factor out the x minus 5. So there we go. There's the AC method worked. So this path was the correct one to take. Now next, we factored the AC method, so next, can what is left inside the parentheses be factored more? So looking at our two parentheses, x minus 5, 3x plus 1. Is there anything else in common, or do we have a difference of squares? Looking at it, nope, there's nothing else. This can't be factored more. So then we have our final answer with this one here. Now we are going to move on to 4-term polynomials, meaning we'll need to use the chart for polynomials that have 4 terms. However, every single chart starts the same way. We check to see, do you have a common factor in all 4 terms? In these 4 terms, is there something, a number or a variable that is in common in every single one of these? We have some things in common in a couple of them, but nothing in all 4. So in this case, we're going to have to follow the no path. So then put the terms in groups of 2 and factor each group separately. If the parentheses in the next step are in common, continue to factor. All right, so we're going to put it in groups then. In the first group, what's in common is the x. We're left with 5x plus 2. In the next group, we have, they can both be divided by 2, and they're both negative, so they can be divided by negative 2. And we're left with 5x plus 2. All right, so part of this step here said if the parentheses in the next step are in common, continue to factor. So let's see, are these parentheses in common? Yep, they are the same. So we are going to continue to factor. We're left with an x and a -2. Next up, can what is left inside the parentheses be factored more? Is there anything else in common in either one of these? Do we have a difference of squares? And no, we do not. So we have our final answer. All right, this will be the last example in this video. Again, we have 4 terms in this polynomial, so we will use the chart for 4 terms. And like always, we start off the same. Do you have a common factor in all 4 terms? Let's check. 6xy, 8x, 18y, 24. I'm noticing that all of these can be divided by 2. So yes, there is a common factor. So I will follow this path. Then divide out what is in common. So they all can be divided by 2. So I'm going to take the 2 out of the parentheses. Then let's continue. So can what is left inside the parentheses be factored more? So first, let's check this one. Is there another common factor? No, nothing else is in common. So then let's try out groups of 2. We're going to split these into groups of 2. The 2 at the beginning, just going to chill here at the beginning of the parentheses and stay there. In common in the first group is an x. We're left with 3y plus 4. In common in the second group is a 3. 3y plus 4 is left. So then, continuing down this path, put the 4 terms in the parentheses into groups of 2 and factor each group separately. All right, we did that. If the parentheses in the next step are in common, continue to factor. Let's see, are the parentheses in common? Yes, so let's continue. The 2 stays at the beginning, 3y plus 4, and what's left is an x and a plus 3. Let's continue. Can what is left inside the parentheses be factored more? Do we have another common factor? Do we have a difference of squares? And no, we do not. So you have your final answer with this one here.